In today's video, here is a nice problem regarding function equation. Here is the following application. So our goal are going to determine all functions from R to R such that we have these following two conditions. Okay, the image of the function is finite, and the second condition for all x as a real number satisfied this second condition, which is f of x plus number 1 equals 8 is multiplied by f of x plus number 7. Okay, what happened here, instead to have infinitely many values for outputs for this f, we have taken the special value of f towards one value as a finite image for this function. The second condition, let's suppose this function is a constant function, because in the other word the function is going to be a constant function. Okay, let's make some exploration and evaluation here. So if f of x equals m, okay, for all x as a real number. Okay, if this function is going to be written on this form, I'm going to solve this equation and to see what this function is going to be. Okay, the whole function is going towards one value, which is m. I'm going to replace this m as a constant function into here, so I get 8 f of m plus 7, which equals m. Okay, so replacing f of m with m, so which means I get 8m plus 7, which equals m. This one is going to give us m equals minus number 1. Thus f of x is taking the value which equals minus number 1. Okay, which means this function is clearly is a constant function, but we are going to prove this one. We need to prove this one. Okay, to prove this one, I'm going to go by the way of contradiction. We are going to suppose this function is not equal to minus 1. We will find the contradiction at the end. Okay, so by the way of contradiction, suppose for all x as a real number, so we get f of x equals the value c, which is different than minus number 1. Okay, so let's take the sum values of x in order to see what's the general expression of this one. Now let's take the special value of x. Let's take f of, for example, f of k, which equals c, is different than minus number 1. Okay, since f of x equals c is true for the special value. Okay, so I'm going to replace this k into this one, so I get here f of k plus number 1, which equals 8 is multiplied by f of k plus number 7. I'm going to replace f of k with the number c, so I get 8c plus 7 plus, if you take a look up here, we get 8c is 7 equals 8 minus number 1. Now let's go to the second expression. So I get f of k plus 2, so I'm going to, which equals 8 by using the origin expression here. So I get f of k plus number 1 plus number 7. I'm going to replace f of k plus number 1 with these things. So I'm going to replace f of k plus number 1 with these things. So I get here 8 is multiplied by 8c plus 7 plus 7. Okay, this one is clearly is going to give us 64, which is 8 square c plus 7 is multiplied by 8 is 56. 56 plus 7, which is 63. 63 is the same as 64 minus 1, or 8 square minus number 1 plus 8 square minus number 1. So it looks like it's going to be on the same pattern. So we get here number 1, we get here the exponent 1, we get the exponent 2, since we have 2 here. Okay, also is 2, we get number 1 here. So this third value, get f of k plus 3 equals 8 is multiplied, always using the original expression. I get f of k plus 2, replacing x with k plus 2, plus number 7. I'm going to replace these things into this one. So we get here 8, replacing this quantity here, So get h square plus c, h square c plus h square minus number 1 plus 7. Okay, doing the same thing here. So I get 8 cubed c, this one you get 8 cubed minus 8 plus 7, which is minus number 1. Okay, it's more clear. We get the exponent 3 as well as this one, minus number 1 everywhere, and then number 3 here. So this one, now let's claim, since this one is going all the way down on the same parallel, this one is going to be true for of f of k plus n, which equals 8 to the n is multiplied by c plus 8 to the n minus number 1. Okay, for all n as a natural number. Okay, to n is a natural number. Now we are going to prove this one. We are going to use the induction hypothesis. The base case is already gone with these 3 values that I have calculated. So let's assume this one is true by using mathematical induction. So we get f of k plus n plus number 1. So we need to prove this one is true also. So I'm going to do the same thing as I have done previously. So we get 8 is multiplied by f of k plus n plus number 7. Replacing f of k plus number n with these things. So I get 8 is multiplied by a to the n c plus a to the n minus number 1 plus number 7. This one is clearly going to give us a to the n plus number 1 is multiplied by c plus a to the n plus number 1 plus minus 8 plus 7, which is minus number 1. It's more clear here. We have proven this one. Now our assumption is true. This one is true. So this condition is going parallel with the constant function. Okay, we are saying this one is a finite, which means all the values we have taken in domain are having the same pre-image. Okay, so if I'm going to, there exists k1 different than k2. If you are taking the constant function like this, this is the constant function. The constant function is always parallel to the horizontal axis, which means all the values of x1, x2, and all the way down to the xn are having the same image, which is f of x k, for example. Okay, so we are dealing with the natural numbers here. So let's take k1 here, for example, and k2. So they are different values, but they are going to have the same image. Okay, this is what happened here. We are applying this condition on our problem, which means since this one is true, which means I will have f of k plus k1, which equals f of k plus k2, like this, replacing these things into here. So I get here 8 to the k1, replacing n with k1, is multiplied by c plus 8 to the k1 minus number 1, which equals 8 to the k2 is multiplied by c plus 8 to the k2 minus number 1. Cancelling out minus number 1 from both sides. I'm going to take constant value to one side and take over the numbers to the other side. So I get here the following. I get 8 to the k1 minus 8 to the k2 is multiplied by c, which equals 8 to the k2 minus 8 to the k1. Since k1 is different than k2, so now this one is different than 0, we are going to divide both sides by the same number. I will be ended with c equals minus number 1. Okay, c equals minus number 1. It's a contradiction. It's impossible because we have chosen c must be different than minus number 1. At the end we found c equals minus number 1. This is contradiction, which means our assumption was true. This is true, which means f of x equals minus number 1. So I have done this problem. Thank you for watching. I will see you next video. Bye.